Okay. Can you hear me? Yeah. Okay, so good evening. I'm Stéphane Landel, and this is Romain Certelon. We both work for a French consulting company named Business Information, and we are both committers on Gatling, which is the stress tool we'll be talking about tonight. When we started this project about 1.5 years ago, there are already many other stress tools. There were, for example, open source projects such as JMeter or Grinder. There were also commercial products such as LoadRunner. I had to use some of them, but I wasn't very satisfied with them. For example, I found most of them to have performance issues, which is quite ironic for stress tools. I often had to build real clusters of injectors in order to produce the expected load, mostly because the tools had consumed too much CPU and too much RAM. The first reason for this bad performance is that quite often they are built on top of a one thread per virtual user architecture. That's how you built concurrent applications 10 years ago, but that's not how you should build things nowadays. If you run 50 threads on a JVM, your application should run fine. But if you try to run hundreds or thousands of them, things will start being really quite ugly and messy because of the context switching. Second problem is that most of them use blocking IOs. So you have all those threads that expect very expensive resources. If you have a closer look at what they actually do, you'll realize that they spend most of their time, first of all, waiting, blocking after sending a request, waiting for the response to come back. And things are even worse than this because here we're talking about a stress tool. So in this kind of architecture, your threads are supposed to simulate real users' behavior. And real users don't immediately send a new request after receiving a response. They take time for example, reading the page before sending the next request. That's what we call think time. And how do you implement think time in a one thread per user architecture? Well, that's actually very easy. Just make the thread sleep. Okay? So honestly, this is a bad thread usage. You shouldn't be using threads like this. Is this performance problem a real problem for you? Well, it depends on your use case. On this slide, you can see the official JMeter benchmark. And it's a very basic benchmark. It's just supposed to produce a very flat, constant 300 transactions per second injection rate. But as you can see on here, the injection rate quickly starts to oscillate between 200 and 400. So in these conditions, you can't really trust your results because when things start slowing down, you can't really be sure if the problem comes from your system under test or actually comes from your injectors. Usually you have to monitor your injectors too. So that's quite complex and risky. My second point with other tools was about usability. Most of them provide a graphical user interface, some ugly, some very sexy, but in the end, I don't feel like a graphical user interface is very suited for this need. For this use case, what I want to do is just open a file, read it through, and get the global picture of what my test is doing. And I can do that with a graphical user interface if I spend time opening menus and boxes and etc. So I don't think that graphical user interface is really suited for this use case. My last point was about maintainability. What I like to do is integrate the stress test into the life cycle of my application, meaning that I want to store my stress test sources along with the application sources into my version control system. And I can do that if my test sources are actually a huge bunch of XML, maybe several megabytes. So we decided, the both of us, to start on project. Here is Gatling. We started 1.5 years ago, And the project is quite healthy. We have new committers, we have contributions. We have frequent new releases with new features and bug fixes. The architecture is quite different. Here you have a purely asynchronous engine based on an actor model, thanks to the amazing Akka framework. Here your users are not threads. There are messages that are passed along chains of actors. And for example, if you want to simulate a pause, you just schedule another message. Okay. Of course, we don't use blocking IOs. Here we use async HTTP client on top of Netty. With Gatling, you don't get a graphical user interface. Don't ask for one. You probably won't get one. Here, your simulation, your scenario scripts are actually real code and actually Scala classes. For those who don't know Scala, don't be afraid. That's not that complex, and you get a quite user-friendly DSL that we developed. Here is an example. Here you can see a very simple scenarios with 2 GET requests and 1 POST request. You can see the POST parameters, and you can see on the last line, you see a check. This is a validation on the response. Here it uses a CSS selector. The DSL is quite rich, so as I said, you got checks. You also have control structures, such as conditional blocks, if. You also have loops. You can handle errors. For example, you can retry on a chain of actions until they succeed. And you also get feeders. Feeders is our API for injecting external data into your simulation so that all your users don't play the same data. Of course, as your simulations are real classes, real code, you can write code directly inside your scripts in Scala. Also, the DSL provides many hooks where you can pass Scala lambdas. So you can develop your own customizations. Of course, you don't have to start from scratch. You can use the recorder. You just set up your browser to use it as a proxy, and it will act as a man in the middle. It will catch your HTTP traffic and build up a scenario embryo, so you don't have to start from scratch. Gatling can integrate with many things. For example, we have a Maven plugin, so you can launch Gatling from Maven. You can use the Maven archetype to build a project and run Gatling inside your IDE. You can also integrate Gatling with Graphite, so you can get live reporting, and you can also consolidate data reports with data coming from the injectors and from the system and the test. So, for example, you can match slowdowns happening on the servers, on the injectors, with, for example, garbage collection happening on the server. There's many more features to come. The Jenkins plugin is actually almost done, and for example, we'll support other protocols than HTTP, for example, WebSockets or JDBC. Well, many more to come. So now, time for a demo and time for Romain to speak.
So now we are going to show you how to use Gatling. So to show you how easy it is, we will use the Play2 computer database sample as an application to test. So the first thing to know is how to get Gatling. So as Stefan said, there is the Maven archetype, but you can also download it as a bundle. Just unzip it, and you can edit or create your scenarios with your favorite text editor, and run the simulations through the command line. So here Stefan is creating a new project in Eclipse with the Maven archetype. So it is just like the usual thing when you use Maven. And once this is done, you have all you need to run Gatling, so the engine, the recorder. And now you have to bootstrap your simulation. To do so, you use the recorder, which is actually the only graphical user interface we have. So as Stefan said, it acts as a proxy, so you can set the ports on the right. You can also set useful information for the simulation, such as the package name and the class name, because the scenarios are code, so they are classes. There is a useful feature, which are filters that allow you to include or exclude the requests as you wish. Once you have completed your configuration, you just have to start the recorder, get to your browser, and start recording use cases. So here we will record 3 use cases for the demonstration. The first one will be a search. So a user would search for a MacBook, for example. And once the search results come, he clicks on the MacBook Pro. The next use case is browsing the computer database. So from the first page to the second page and so on. And the last use case will be an edit of the database, so creating a new computer. So you just provide data as you must, and then it's okay. So once you have finished recording your scenarios, you just have to stop and save it, and it will appear on the Eclipse, as you might expect, in the right package.
Woohoo!
So this is what simulation looks like. So you have the package name as you specified, the class name also, and everything is defined under in the apply method. So you have 4 blocks in the apply method. The first one is the HTTP configuration. So it will be used by every request in your scenario. So you can set the base URL, for example, which is a factorization of the base URL of all your requests. And you can easily change the server under test, for example. Next, you have all the common headers of the scenario, so the accept header, the do not track header, and so on. They will likely not change during the simulation, so you can set them here. Next, you have header declaration. So you can see it's a content type header. It is used in the post request. So here we have to specify this header. So it has been set like this by the recorder. And next you have the scenario description. So you can see there are 3 things. The first is the execution, which corresponds to an action. Basically, it is always an HTTP request. Next, you have the pauses, which corresponds to the think time of the users. And the last thing are the tags that Stefan put in the recorder, so you can see your different use cases easily. And the last block of the simulation here is the simulation configuration. So you can here configure your scenario, say I want 1 user, this is the default, and use the HTTP configuration I defined earlier. And when you will run it, Gatling will use this to run the simulation. So now we are going to reorganize the code, because as in Selenium, you will do use a page object pattern, to organize your tests. Here we choose to organize our requests and the pauses as use cases, so we can reuse them later. So we use objects in Scala, which are singletons in Java. They are as simple as this in Scala. And we separate the scenario, we split the scenario in 3 use cases. So you might have noticed, that the pauses have different values. These values are computed by the recorder when you navigate through your website. So you can set up the recorder and make your users use the application as they would normally do. So you can get actual realistic user behavior. So this is the last bit.
Almost done. Yeah.
So now we can rewrite the scenario like this. Compose all the use cases. Search. You can see that we can benefit from the auto-completion because we are in Eclipse. That's it. So now what you might want to do is to create different populations of users, for example, administrators and users. Here we can create 2 populations, so the same as I said earlier. Users, which should have only search and browse rights, for example, and administrators which would be allowed to edit the database also. Once this is done, here the scenarios are defined but not used in the simulation. So you have to specify in the simulation configuration that you want to use the administrators also. And you can set the number of users here, 1,000, and use a ramp. So a ramp is here, for example, all the 1,000 users will be started in 5 seconds. So the server can have the time to warm up, and you will not hammer hit, which could lead to strange results. Okay, so here we have a simulation that's quite nice. We are going to show you some features of Gatling now, of the DSL. So the first thing to do is to rename the requests. You can specify names here that will be shown in the reports, so you can identify the requests that were made by Gatling. We are setting the poses to lower values because of the time we have for the demonstration. And the first thing we want to show is a check. So we want to verify that we land on the computer page. This is the last request, so we check that the status is actually 200, saying it's okay, everything went fine. So this is it for a check. This is very easy. What we want to do now is make our different users use different values for the search, because if they all call the same values, there could be a server-side optimization, which is not quite good, because we want to make a performance test. So we have to make this MacBook parameter dynamic. To do so, we will use a feeder. So feeders are just wrappers around data sources. So here we will create a CSV file. So you can name it whatever you want. We will put data in it.
Okay.
Basically, two records with, you can see the title, search criterion, and search computer name. So once this CSV file is available, or it could be also a JDBC a database, for example, you just have to define your feeder in the simulation as a CSV feeder using the search.csv file. Use it in your scenario. And here, every time a user will pass through this feed keyword, a record will be popped from the feeder. So the default implementation is a queue. So we have only 2 values. At the third user, it will fail. So we make it a circular feeder, so we can have as many values as we want. Next step is to use actually the values injected in the scenario, in the session. So we can use the Gatling expression language to get the values we want. So here the search criterion expression language will get the value stored under the search criterion key in the session. Here our users will search for different computers, but they all get to the same page, the same computer page, which is not what we want. So what we are going to do is to get the URL of the next page from the previous page. Am I clear? So here we will use a regular expression check, saying that we want to capture the URL in the good link. So here the MacBook Pro link, for instance, and save it in the session as computer URL. So now we can make the URL of the next request dynamic with the expression language. But this is almost done. Now we just have to provide the good name, the good computer name. So we provided it in the feeder, so we just have to use it now with the expression language inside the regular expression. So this is it for the search use case. Now we get to the browse use case. So here you can see a pattern repeated. We are making 4 times the same request. So we have a request to page something and a pause. So what we can do, because this is Scala code, is create a new method. This method will go to a certain page, a given page, sorry. And that's it. So now we are saying that this request will go to page with the good query parameter. So we can now replace all of this with 5 calls or 4 to the same method, from 0 to whatever you want. Here it is. But this is not dry yet, because if you want to make a call to 7 pages, you will have to copy-paste the code as many times as you need. So we can make another method named goToUntil. So this method can use the DSL keyword named repeat to say we want to repeat page 2 times, saying that this is a page as a string and we want it to be an integer, and call the goToPage. But this is not what we want yet. What we want is to use actually the good value for the goToPage, because here it will go to the last page as many times as we specify. So we can use the loop index. So we declare that we want to use it in the loop, and then we can use it with the expression language. And we can rewrite the browse use case as a single method call. That's it for this use case. So now we can go to the edit use case. The edit use case is quite similar to the first one in the meaning that we could use a feeder to provide different data that will be recorded in the database. But we won't do it now because of the time we have. What we are going to show, however, is how to handle errors in Gatling in the DSL. So here, the request is going to be fine, normally. So what we're going to do is to make it fail randomly. So we use a check on the status, and we will have the expected value of the check be either 200 or 201. For this, we will use a random generator number that comes from Java. So you can use any library, in any Java libraries you want in Scala. This is quite useful. And then you can use a Scala lambda here, a function, to say here the status should be 200 or 201. And this would fail 1 time over 2 statistically. So this is it. So this failure can be compared to a login failure, for example. Your user will come to the application, try to log in 1 time, it will fail. So usually they will try 2 or 3 times. So what we want to do here is try this request a given number of times. So we use the try_max keyword. So here we will try this request twice before we say it fails. And if it is a login request, you might not want to continue the scenario if the 2 attempts failed, because there will be no meaning. So here you can just specify exit here failed. So that's it. We have shown you many features of the DSL. So now we just run the simulation. So you can choose the simulation you want to run. You can give some details that will appear in the reports, and then the simulation runs. So when it runs, you can see the console dashboard here. So you are seeing the running users. Oh, fail.
Excuse me.
Oh, strange.
So what happens?
Oh, this is the demo effect.
Too many of them.
So the play application. Seems good.
I'm not really sure. Okay. Okay, let's try list users for this application. Seems to be 100. Starting play again.
So here you have seen that many requests failed, so we know that something went wrong. This is quite helpful sometimes, sorry, because if you want to start a run that will longer for 2 hours, you want to stop it if you know that it will not succeed at all. So now we can just run it and cross our fingers.
Hopefully. Oh, sorry, didn't start the right one. Again.
So here it is again. Oh yes, this time it seems to be right. No, not yet. So
No, that's okay. That's the expected checks that fails randomly.
Yes, sorry.
That's fine.
So you can see the expected failures of the administrator use case. And okay, so when it's finished, you have a link to the reports. Reports are HTML, so you can easily share them with anyone. And they contain useful information about all the requests that were sent by Gatling during the simulation. So here you have a table, for example, showing how many requests succeeded, failed, different values for the response time, and so on. We can see here different charts that are showing what happened during the simulation. Here we can see the different sessions, so for administrators, users. Here we can see the number of requests per second. So we are here already at 400 with a small use case. So this is quite nice.
And you can zoom also.
And if you want to have information about specific requests, you can just access them. These are the same things, just for one request. So that's it for me.
Well, Gatling is quite efficient. We're satisfied with the results. Here you can see how Gatling behaves on the JMeter benchmark. You can see that it produces the expected transactions per second. If you want to know more about our project, you can go and visit our website, gatlingtool.org. You can also check out the code that is hosted on GitHub. And you can follow us on Twitter. Okay, thanks for listening. If you have any questions. Yeah.
Can you also use Gatling to functionally test your application? Because I saw that you check that the application contains certain...
Yeah. So the question is about how do you can use Gatling for functional tests. You can do this if, for example, you have APIs, web services. Gatling is not a browser. It won't ever be because it's just not doable to run JavaScript and stuff like this. So it's perfectly suited if you just want to run a functional test of APIs, such as JSON or even SOAP if you want. Another question? No? Here, yeah, excuse me.
Did you also look into improving one of the existing frameworks instead of adding another one?
Yeah, that was 2 years ago. For example, I mostly use JMeter and the grinder. JMeter, the core architecture is too different, as I explained. There's too much code base on this one thread per user architecture, and the grinder also uses this kind of architecture. I later heard about Tsung, which is written in Erlang and which is an asynchronous engine, but that was too different from what I was used to, and I didn't know Erlang at that time. And it's always easier to sometimes it's easier to start a new project than trying to convince people who've been developing on the project for many years that okay, that should maybe completely break stuff and redo things. Okay, thank you.